In this video, we're going to explore what is phantom power. In Pro Audio, we use phantom power to power up microphones such as the condenser microphone over here. There are two ways to power a condenser microphone in our industry. The most common way is to send phantom power directly into the microphone to charge up the capacitor inside the microphone for it to work. Something like this, a SM58, on the other hand, is a dynamic microphone which does not require phantom power. So we will also explore what happened to the SM58 if we accidentally send phantom power to the microphone itself. So what is phantom power and how does it work? Typically, we use a console. It can be an analog console, it can be a digital console, where we will take the XLR cable and send phantom power through that cable directly to the microphone. And from this diagram over here, we realize that all of this XLR pin out, pin 1 the ground, pin 2 the positive, pin 3 the negative. We can measure that from pin 1 it's your ground, so that's 0 volt. Pin 2 you get 48 volt. Pin 3 you get 48 volt also. So what happens if you measure pin 2 and pin 3 at the same time? Do you still get 48, or do you get 96, or you get 0 volt? We will explore that later on. So without further ado, we will move on to our demonstration. Right, in this scenario, we're going to attempt to measure the actual 48 volt that's coming out from the analog console over here. So this setup consists of an analog console with an XLR cable that's terminated with a bare end like this, that's going into a DMM, or what we call a digital multimeter. Okay, so this particular scenario, we're going to try and measure the ground to pin 2, which is the blue cable over here. In this case, we should get a 48 volt. Let's try. As you can see from the DMM, it's showing 48 volt, and this is true because on the DMM itself, the red color probe, which is this probe, is the positive port, is connected to the pin 2 over here. The negative probe is connected to 0 volt over here. So 48 positive minus 0, you will get 48 volt over here. Now, we'll move on to the next scenario where we'll try and measure between pin 3 and pin 1. So now you can see we are measuring pin 3, the white cable, on the red color probe, which is a positive probe, and the ground cable, which is the black color probe, which is a negative probe. So in this case, we're going to try and measure and see what type of voltage do we get in this setup. Again, we get 48 volt, and this is true because on pin 3, the voltage is plus 48. Pin 1 is again 0, so the red color probe is positive, so it's 48 minus 0, you still get 48. Now, let's explore the next scenario where we're going to probe both pin 2 and pin 3 together. Will you get 96 volt, or will you get 48 volt, or do you get something different? Let's try it out. So what you can see here is my positive probe, the red color one, is connected to the blue wire here, which is pin 2. The negative probe, the black color probe, is connected to pin 3, which is the white wire over here. So let's see what type of voltage do we get over here. Now, this is 0 volt. So what is happening over here? Now, if you look at this, this is pin 2, which outputs a voltage of positive 48 volt. And this is connected to the red color probe, which is again positive. The pin 3 is again plus 48 volt, and it's connected to the black color probe, which is negative. So the reason why this is getting a 0 volt is because red color probe plus 48 minus 48, what do you get? 0 volt. So in this case, when you measure both pin 2 and pin 3 together, you will get 0 volt. And this is, in the electrical point of view, there's no potential difference over here, which is why this is 0 volt. Now, previously we had tried and measured the phantom power coming out from the analog console, and we are able to measure the voltage to be at 48 volt at the DMM over here. In this experiment, we're going to try and see what happened to the phantom power voltage if we now plug a condenser microphone into the analog console. So now the DMM is showing 48 volt. What do you think will happen? Will the voltage go up? Will the voltage go down? Or will the voltage remain the same? Now, we're going to try and plug this in. What do you observe over here? We can actually see that now, instead of the DMM showing 48 volt, the voltage has now dropped to roughly around 42.7 volt. And this is true because a condenser microphone, you can view it as an electric device. For it to operate, it needs some power to operate. So the reason why you drop from 48 volt to 42 volt is because there's some electrical loading coming out from this condenser microphone over here, which is why you will actually measure a drop in voltage instead of an increase in voltage. So this is the characteristic of how or what happened to the phantom power if a condenser microphone is plugged into the analog console. Next, we're going to try and see what will happen if we plug a dynamic microphone into a console that is sending phantom power. Conventionally, a dynamic microphone like this do not need phantom power because it does not have any active component inside the microphone itself. So what happens if you are using a dynamic microphone and phantom power? Will it damage the microphone? What will happen to it? Let's find out. So again, you can see that the connection is still now bare. There's nothing, it's unloaded. There's nothing connected to it right now. And you can see from the DMM, it's at 48 volt. Okay, so let's see what happened. What happened? The voltage seems to stay the same. What does it mean? Well, it means that although there's a device that's connected to the console at channel 1, which is the dynamic microphone, but it seems like the voltage is unused. Well, if you remember from our previous scenario where we try and measure pin 2 and pin 3, which is 48 volt and 48 volt, if you use a DMM to measure pin 2 plus 48 volt, and the negative, which is the black color probe at pin 3 minus 48 volt, what do you get? 48 minus 48, you get 0. In this case, you realize that even though there's phantom power going into the dynamic microphone, but because both pin 2 and pin 3 it's being used, what the microphone is experiencing is 0 volt, which is why a dynamic microphone will still work despite that there's phantom power in the transmission line itself. In this scenario, we are connecting two consoles to a single microphone like this. So we are going to try and see what will happen if we have two consoles sending phantom power to one microphone. If we turn on the phantom power over at this side, what we can see is the DMM is showing 48.6 volt. Okay, and this is quite true because from the previous three scenarios, when we measure the voltage from pin 2, which is 48 volt, and pin 1, which is 0 volt, so 48 minus 0, you will get 48 volt over here. Now, the question now is, if we turn on the phantom power over at the other console, what will happen to the voltage? Do you get 96 volt, double the voltage? Do you stay the same as 48 volt, or will you get 0 volt? So let's find out. So I have turned on the second console over here. Can you see that the voltage stays about the same, which is still at 48 volt? So what's happening over here? This is what we call a parallel circuit, where this console, console A, is parallel to console B. Through your electrical education, you learn that in the parallel circuit, voltage 1, V1, will equal to voltage 2, V2, will equal to voltage total, VT. In this case, even though there's two phantom power source sending phantom power to the multimeter, because it's parallel, the voltage stays the same. But what's different? The current is now double because there's two console coming into a DMM. So the voltage stays the same, 48 volt, but the current is now double. Okay, now if we now plug this condenser microphone to the input of both console, let's see what will happen. So I'm going to plug this in. Can't you see that it drops to 46 volt, which is higher than the previous scenario where earlier on when we plugged the condenser microphone into the input, we actually get 42 volt. So this shows that even though you have two phantom power source, namely console A, console B, when you plug your input with a condenser microphone, your microphone will still work like this, but at the same time, your 48 volt doesn't drop that much. In this case, we drop to roughly around 46 volt. The next scenario, what will happen if we use a dynamic mic instead? So again, we're going to use a SM58 and we're going to plug the input into both console with phantom power on. So can you see that the voltage stays about the same, 48 volt, but this time round, my input will still go to console A and console B, like this. So this scenario explains the phenomenon where we have console A sending 48 volt, console B sending 48 volt, and in total, we also get 48 volt because V1 equal to V2 equal to V total. But take note, the current is now double. And you can use both condenser and dynamic microphone to go into the same two console when you have 48 volt.